Good morning, students. Today is our sixth lecture of our plus two of the chemistry subject. In this, in our previous lecture, we have discussed about we have started the new chapter that is a unit 8, that is the D and F block element. In that, we have discussed about the group transition elements. Yana configuration of a transition elements. These have we discussed later. In this, firstly, we are discussing about the D block element that is called a transition elements. And today I am giving you a trick how can we remember these elements of a D block elements. Firstly, first we have to fill the electrons on in 3D. And which period is there? Fourth period. In second, fifth period, we have to fill the electron in a 4D orbital. In a sixth period, we have to fill the electrons in a 5D orbital. So that's why now we write n minus 1d, ns1 to 2. This is the n configuration, means less than 1. If the period is fourth, we have to fill the electrons in a 3D. If the period is fifth, then we have to fill the electrons in a 4D. If the period is sixth, we have to fill the electrons in a 5D orbital. Now first we have discussed about the period fourth, about the 3D orbitals. In a 3D orbitals, which elements are present, that is the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. How can we remember this series? That is the science teacher, very crazy, science teacher, very crazy, मांगे फीस, कोर्स नहीं कंप्लीट जरा भी. Clear na? How can we remember the 3D transition? That is the science teacher very crazy, मांगे फीस, कोर्स नहीं कंप्लीट जरा भी. This is the way, this is a trick to remember the 3D transition, or we can say that fourth elements of a D block element that is present in a fourth period. Next, that is the period fifth, and we have to fill the electrons in a 4D orbital. How can we remember? यारी यरा निभाना मौत तक, यारी जरा निभाना मौत तक, रुकावट राह में पड़ी तो आग में कूद. जारी जरा निभाना मौत तक, रुकावट राह में पड़ी तो आग में कूद. This is a way to remember the 5D, 4D transition elements. Next, we have to remember the 5D transition elements that is present in a sixth period. How can we remember? La hafta, W ray. These are the most expensive metals: osmium, indium, platinum, gold and mercury. La hafta, W ray. Then we can mention the name of these metals. That is osmium, indium, platinum, gold and mercury. This is a way to remember the transition D block elements. Now, D block elements are vary from a period group 3 to group 12. In this, in a case of a scandium, atomic number is 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Next, how can we remember the atomic number? Then we can add the 18 in this. If we add the 18 in a 21, it becomes 39. Now the 40, 41, 42, 43, 44, 45, 46, 47, and 48. This becomes the atomic number of a second transition series. Now add 18 in next. Then it becomes 57. Here I mention the star means from this F block series is present. Now in a F block elements there are the 14 electrons are present. So 57, 58, 59, 60, 61, 62, 63, 64, 65, 66 कितने हो गए 1 2 3 4 5 6 7 8 9 10 11 12 13 14. These are the elements of a F block element. Now after 71, 72. Hophium is the atomic number 72. After 57, there is atomic number 72 because from these F block series is present. Now it becomes 73, 74, 75, 76, 77, 78, 79, and 80. Clear? These are the most important to remember the atomic number. That is a group 10. That is a nickel, platinum, and platinum. And the atomic number is 28. Then after add 18. If you remember, then in a first add 50. Next is group 11, copper, silver, gold. That is the 29, 47, and 79. And next you have zinc, cadmium, and mercury. That is 30, 40, and 80. Clear? This is about the transition elements. Now next most important question, that is these zinc, cadmium, and mercury. These elements are not included in a D block, in a transition element. Last electron is filled in a D orbital, but these are not considered in a transition element because in a transition elements there is a one condition that we have require the partially filled or the incomplete D orbital. In a case of a zinc, that is a 3D, 10, 4D, 10, and 5D, 10. D orbital is fully filled, so that's why we are not consider them in a transition series. Firstly condition is that they have a require the incomplete or the partially filled D orbital. Second one is they have a partially incomplete in their oxidation state. You say that most important question in your mind. In a case of a copper, silver and gold, they have also filled a d orbital, 10 electron. But if we taking the example of a copper 2 positive in their oxidation state, then it becomes a 3d9. They have a partially d orbital, filled d orbital. So that's why in a case of a zinc, cadmium and mercury, they are not considered in a transition element. Last electron is filled in a transition element, but they are not considered in a transition element. This is the most important question. Which metals are not considered in a transition element? And these elements are called pseudo transition element. Clear? In the next, we have discussed about the general properties. In a general properties, we have a first, that is atomic radius. In a previous data, we have discussed in a p block elements or in a +1 also. We can say that if we are moving along a period from a left to right, then the atomic radius is decreases, and we are moving from a top to bottom in a group, then the atomic radius is increases due to number of shells are also increases. But in this there are the different cases. Firstly, the atomic radius is based on the two factors, that is firstly the effective nuclear charge, the second one is a screening effect. There are the two factors that affect the atomic radius. First is your nuclear charge and second one is a screening effect. Now, along a period, the atomic radius does not vary regularly. We cannot say that along a group that is it is continuously increasing or continuously decreasing. First is from a scandium to chromium. That is in a case of a 3d1 to 3d5. It remains, it is a decreases. Atomic radius is a decreases. Reason is behind it, that is the effective nuclear charge is increases when we move from a scandium to chromium. After chromium, that is the atomic radius of a chromium, manganese, iron, cobalt and nickel, these remain almost same, because in these cases that is the nuclear charge is equal to the screening effect. In the first cases, if we discuss, that is the nuclear charge, effective nuclear charge is more than screening effect. So that's why atomic radius is a decreases. But in a case of a chromium to nickel, that is the atomic nuclear charge is equal to the screening effect. Then it is remain almost the same. But in a case of a copper and a zinc, now they have a filled d orbital in both cases. So that's why screening effect is more than the nuclear charge, and atomic radius is increases in a case of a copper and a zinc, and zinc has a more atomic radius as compared to that of a copper. Clear, beta? Now what is the screening effect? In that case, if we write the configuration up to the magnesium tak le lo, then we have to fill the 3d5. After in a iron we d 3d6. In a 3d6, pairing will be start of electrons. When we filling the electrons, then the pairing will be start. In that case, the repulsion of electrons will be there. So that's why screening effect is increases. In that cases, they are the fully filled d orbitals, and screening effect is more. Repulsion will be more. If the repulsion will be more, then the nuclear charge is decreases. So that's why atomic radius is also increases. This is about the atomic radius then when we are moving from a left to right along a period. Next, we are moving about the atomic radius down the group. In a down the group, we are moved to 3D to 4D and 4D to 5D. Now, what is the variation in this? That is, when we are moving from a 3D to 4D, then the atomic radius is increases. But when we are moving from a 4D to 5D, then what is the reason behind it? That is why the when we are moving from a 3D to 4D, that atomic radius is increasing. That is the reason is that is the number of shells is increases. So that's why atomic radius is also increases. But when we are moving from a 4D to 5D, then the atomic radius is remains same. What is the reason behind it? That is due to the lengthenoid contractions. Due to the lengthenoid contractions, that is the atomic radius remains the same of a 4D and 5D orbitals. Because in this, that is the f orbital are present, f block elements are present, then the f block elements have a poor screening effect as compared to that of a D, as compared to that of a PS, and as compared to that of a S. About the lengthenoid contraction, we have discussed in a f block elements. You just keep in mind that is the 4D and the 5D elements have a atomic radius same, that is due to the lengthenoid contractions. Now we have to make a graph. Firstly, if we are taking the along a period, then scandium, titanium, vanadium, chromium, manganese. Atomic radius is decreases. After that, iron, cobalt, nickel, that remains almost same. After that, copper and it again increases. Clear? Firstly, the atomic radius is decreases up to manganese. After that, it remains the same. After that, it again increases in a case of chromium and copper and zinc, because in a case of a copper and zinc, that is the more screening effect will be there. Now, this is about the period 4th. Now, same in a case of period 5. Same period 6. Means that this is about the 3D, this is about 4D, and this is about 5D. These are we discuss about along a group. These are along in a this is according to the period, and this is according to group. Now 3D has a less atomic size, but 4D has a more atomic size according to this graph. Firstly, continuously they are decreasing, constant and increases. But these two lines are shown. This is of a 4D and this is for the 5D. In a case of a 4D and 5D, that is atomic radius remain same. Firstly, this is increasing. After that, it remains same. This is a graphical representation of atomic radius. Clear? Next one is we are discussing about the short topic again. That is the magnetic properties that we have discussed in a previous class also. In a magnetic character, there have two types. That is the paramagnetic character and the diamagnetic character. In a what is a paramagnetic character? In a paramagnetic character, unpaired electrons are present. In a case of paramagnetic, that is the unpaired electrons are present. But in a case of a diamagnetic, that is a paired electron are present in a orbital. That magnetic effect is called a diamagnetic. But if we are talking about the transition element. In a transition element, mostly the d block element show a paramagnetic character. In this, only a single electron is matlab unpaired electron is present. If we are moving talking about the group transition element 3D or the period 4th, then when we are moving from a scandium to manganese, in a scandium that is a 3D one, and in the case of a manganese that is a 3D 5. Firstly, the unpaired electron will be increases. After that, from iron to copper, that is the unpaired electron will be decreased, because in after that in a case of iron, that pair will be starts of electrons in a orbital. So that's why paramagnetic character is firstly increases, after that decreases. Now we can find also the magnetic movement, and this is the formula to find the magnetic movement of any element or any ion. Firstly, this is a mu. Mu is denoted to magnetic moment, square root of n bracket n plus 2. Here n is the number of unpaired electron, and Bm is the unit, that is called a Bohr magneton. Now we will discuss about one example. How can we find a magnetic movement? If I taking the example of an example Fe2 positive, then the configuration is up to argon, that is remains same 3d 6. 2 electrons are moved from a 4s orbit. Then it becomes 1 2 3 4 5 6. Three d6. Now formula to find the magnetic moment, that is the n into n plus 2b. In this, how many n is represented by unpaired electron? 1 2 3 4. 4 unpaired electron is there. Then is a 4 plus 2, and the square. Then it becomes a 4 into 6 into 24. Then we can write 24 2 12 2 6 2 square root of 6. Now you can find the value of a square root of 6. After that we can find the magnetic movement. In this way we are finding the magnetic movement of any atom or any ion. Thank you.